Picking up where the video left off, we'll start with example 2, which actually asks us not to factor, but to do the opposite, which is to multiply. So when we multiply, we can do one of two things. You can use a sort of a variation on the FOIL method and distribute x to all three of the terms in the parentheses, and then distribute 2 to all three terms in the parentheses. Or you can use the box method. I kind of suggest that for a binomial times a trinomial. So if we're multiplying a binomial times a trinomial, it just kind of helps you keep organized. So I'm going to do a box with 2 rows and 3 columns. X and 2 are the terms of the first factor, or the binomial. X squared plus negative 2x plus 4 are the terms of the trinomial, or second factor. So now multiply x times each of the terms in the trinomial, and then distribute the 2 to each terms in the trinomial, so 2x squared minus 4x plus 8. And now we're going to notice that our like terms line up in those diagonal boxes, and something special happens. Those like terms add to 0, and the only terms left are x cubed and 8. So the product of these two factors is a very special type of binomial. It is the sum meaning addition, of 2 cubes. So it's actually x cubed plus 2 cubed. And the sum of 2 cubes and the difference of 2 cubes are always going to be factorable when we find those in polynomial form. Here are the formulas that we can use for factoring the sum of 2 cubes and the difference of 2 cubes. So when I have the difference of 2 cubes, I'm going to find the first factor by uncubing each term. That's also known as a cube root. So the first factor for a cubed minus b cubed is a minus b, and the first factor for a cubed plus b cubed is a plus b. Now when we construct the second factor, I'm going to square that first term, and that will give us a squared. And then I'm going to take the first term and the second term and multiply them. That gives me AB, and then I'm going to square the second term, b squared, and then I'm going to use these opposite sign and always plus here. So there's a way that you can help remember this, and I'll run through this square squish square as I do each example in example 3. All right, so factor each binomial. So what you're going to recognize here is that k cubed plus 64 is the sum, that is the addition of 2 perfect cubes. It's the cube of k and the cube of 4. So as I construct my first factor, I'm just going to uncube those numbers, and then for the second factor, square the first, squoosh the 2 together. That means 4 times k. When we squoosh in math, that means that we're not writing the operation symbol or multiplication. And then I'm going to square the second factor, 4 squared. Now what I'm going to do with the signs is I'm going to match the same sign as in the original. So since it was k cubed plus 64, the first factor has k plus 4. Then I'm going to use the opposite sign and then always plus. That's MOP. Match opposite plus. Now I'm just going to simplify. So simplifying, that's k plus 4 times k squared minus 4k plus 16. And you may be wondering about that final answer, since there is a trinomial as the second factor. You may be wondering if that factors again. If we're looking to factor that again, we would be looking for factors of 16 that add to negative 4, and there aren't any. As it happens in the sum and difference of cubes, that trinomial factor will be prime. That is to say, it won't factor again. All right, in B, we're going to recognize this as the difference of two cubes. So that is 2x, the quantity cubed, minus 3y, the quantity cubed. So I'm going to construct the first factor, 2x and 3y, just uncubed, and then square the first, so 2x times itself is 4x squared. Now squish them together. 2x times 3y is 6xy, and then square that second factor. 3y times itself is 9y squared. Now I'm going to do the signs. I'm going to match the sign of the original, minus, and then I'm going to use the opposite sign next, and then always plus. So there are our factors for 8x cubed minus 27y cubed. You can always multiply those factors back together just to check to see if you have the right terms and also to see if the right signs are there. All right, in C, y cubed minus 729, you're going to recognize this one as y cubed minus 9 cubed. So that's going to factor into a binomial times a trinomial. To construct the binomial, simply uncubed y and 9. And then square the first, that's y squared. Squish them together, that's 9 times y. And then square the second, 9 times 9 is 81. Then I'm going to match the same sign as the original, use the opposite sign, and then always plus. For D, letter D, you're going to recognize this as mn, the quantity cubed, plus 6 cubed. Now, unlike squares, remember the sum of two squares is prime, the sum of two cubes is not. We can factor it. So I'm going to construct my binomial factor by just uncubing. So mn and 6 are the terms. And then to construct the trinomial factor, square that first. That would be m squared times n squared. Then squish them together. That's a 6mn. And then square the second. 6 squared is 36. And now I'm going to insert the signs, match the original, use the opposite sign, and then always plus. All right, in E. Why don't you pause the video at this point and have you try this one on your own? So let's pause the video while I try this. All right, did you get 8a plus 1 times 64a squared minus 8a plus 1? Great. Now let's move on to F, and again, let's have you try this one on your own. Pause the video while you do this. All right, did you get 5ab minus 7 times 25a squared b squared plus 35ab plus 49? Great. All right, now we're going to move on to factoring completely. Remember, factoring completely, we always want to start with the greatest common factor. So we're going to factor out a GCF if at all possible. First, in A, our terms are in order, starting with an m to the fifth, and then a term with an m to the 1. So they are in descending powers. Secondly, I'm noticing that the first term has a negative coefficient, so I know I'm going to factor out the negative of the GCF. And 2 is a common factor of 32 and 162. It's the greatest common factor. And then m is also a factor, so we can factor out a negative 2m, and that will leave us with 16m to the fourth minus 81. Once we get that, we're going to examine the binomial in the parentheses and see if it factors again. So I'm just going to bring down that GCF, and this is the difference of two perfect squares. So that will factor again. That's the difference of two perfect squares. Recognize that that is 4m squared and 9 squared. So when we have the difference of two squares, that factors into 4m squared plus 9 times 4m squared minus 9. I'm going to continue to bring down the GCF factor. Next, I'm going to look at 4m squared plus 9. That is two perfect squares, but they are added, which means that that factor is prime. We're not going to write prime, we're simply not going to factor it again. Then 4m squared minus 9 is the difference of two squares, so it can be factored again. 4m squared is the square of 2m, and 9 is the square of 3, so 2m plus 3 times 2m minus 3 is what that factors into. And now all the factors that remain are prime, that is to say they can't be factored again. For b, we're going to factor out the GCF first, or the greatest common factor, which is 7. So 7 times x cubed minus 8. I'm going to bring down that GCF factor, and x cubed minus 8 is the difference of two perfect cubes, and those two perfect cubes being x and 2. So I'm going to construct the binomial factor, which will have terms of x and 2, and then square, squish the x and the 2 together, and then square the second term. So square of 2 is 4, and then I'm going to match the sign, use the opposite sign, and always plus. So there is my end result. Notice that we're not going to factor the trinomial, because when we factor the difference of cubes, the trinomial that remains does not factor again. It is prime. There are no factors of 4 that add to positive 2. All right, this one's a fun one. N to the 6th minus 64. Both of the expressions in this are both squares and cubes. The hint here says it's going to be a lot easier for us if we start by factoring it as the difference of squares. So if we think of this as the difference of squares, we are thinking of it as n cubed squared minus 8 squared. N cubed squared minus 8 squared factors into n cubed plus 8 times n cubed minus 8. Now we can factor each of those expressions. N cubed minus 8, or n cubed plus 8 rather, is the sum of two perfect cubes. That is the sum of the cubes of n and 2, so constructing the binomial factor, n and 2, square, squish them together, and square the second, and then match, opposite, always plus. Now we're going to factor also the n cubed minus 8. We're going to use the same terms with different signs for this one. Square, squish, square, match, opposite sign, and plus. And now we have 4 factors that multiply together to give you that expression with an n to the 6th minus 64. In example 5, we're going to find the solution set for each equation. We're going to continue to utilize factoring as a method to solve each of these equations. In A, we have a binomial w squared minus 361 equals 0. Recognize that 361 is 19 squared. That means that this is the difference of two perfect squares, which will factor into w plus 19 times w minus 19. And if two factors multiply and the result is 0, then either the first factor equals 0 or the second factor equals 0. Subtracting 19, adding 19. Our solution set includes two opposite numbers. Now you can give your solution in that way if you want to use that shorthand plus or minus. That just means that we have positive and negative 19 as possible solutions. In B, we have an equation where we have variables on both sides. It might be tempting to divide both sides of this equation by x, but in doing so, we'll lose a solution, so we want to avoid that. If we divide by x, we would just get 4x squared is equal to 49. That's going to give us two solutions, and this is a third degree equation, so we're expecting 3. So instead of dividing, I'm just simply going to bring all of my terms to one side so that we have a 0 on the other, and then factor the greatest common factor. And now factor the difference of squares. 4x squared is the square of 2x, and 49 is the square of 7. So the two factors of 4x squared minus 49 are 2x plus 7 times 2x minus 7. Now we have a product of three factors equal to 0. So either the first factor is 0, or the second factor is equal to 0, or the third factor is equal to 0. One of our solutions is 0. If 2x plus 7 is 0, we're going to find the solution by subtracting 7 and dividing by 2. That gives us a negative 7/2. And our second solution, our third solution is found by, in the third equation, adding 7 and dividing by 2. So that's positive 7/2. So there are three solutions to this equation. Let's pause the video while you try C on your own. Here is the solution to C. Our solution set contains both positive and negative 5/9. Now let's pause the video while you try D. Remember to avoid the temptation to divide by a variable. This was a third degree equation, and so, as expected, we got three solutions: 0, -2, and +2. And that's it for this lesson.